So you can see here, when we do this gesture, it controls the robot dog to move forward, and you can make it go back.
Hello, everybody. I'm Dr. Satya Mallick, CEO of OpenCV, and it is good to be back. OpenCV Model Zoo is a free open repository from OpenCV that has come together in the last several years as machine learning has evolved. It contains dozens of models benchmarked on real hardware like NVIDIA Jetson and Raspberry Pi. Today, one of the team members who has been working with Model Zoo joins us for showing and telling. Yuantao Feng, welcome to the show.
Thank you, Satya, and thank you, Phil.
So Phil, also with us is Phil Nelson, Director of Content and Creative. Phil produces the show. And as you know, if anything goes wrong, it is all his fault. Hello, Phil.
Good morning, Satya. Welcome back. It's good to have you back after a couple of weeks. It's hard work doing this without you. Speaking of hard work, a happy and elevated 420 to all who celebrate. It was a great way to start it by watching that big stupid rocket explode. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you can call me Phil, and I'll be your Huckleberry. But first, I'm here to remind you of a few things we do every single week here on OpenCV Weekly Webinar, the first of which is a giveaway to you in the audience. Stay tuned later in the episode. You will have the opportunity to answer a trivia question in the Zoom chat, available at available at opencv.live. If you're not in Zoom, you can get there by going to opencv.live to participate in the trivia giveaway later in the show. You'll answer a question. You'll get to win the OpenCV course of your choosing. So stay tuned for that. We're also taking questions from you in the audience during the whole show. Ask your question in the chat system wherever you're watching us, or use the Q&A button at the bottom of the screen here if you're watching us in Zoom. We will do our best to answer every question in context. If there isn't any, we'll save some time at the end of the show and try to ask your questions at that time. So stay tuned. Satya, back to you.
Well, welcome, Yuantao. We are very, very excited to have you on the show. And let's see what you have got. You can start with a short introduction and then share your slides. I'm very excited to hear what we have on OpenCV Model Zoo, which we have not promoted until a lot until today. So we'll see what are the models available there.
Yeah, welcome to the show. No pressure, but this is episode 100.
Ooh,
that means a lot. Yeah. Okay. Let me see. Okay. Okay, hello everybody. Good morning, good afternoon, or good evening, depending where you right now. So my name is Yuantao Feng. I'm from China, and our team is OpenCV China. And today I'm going to introduce you our OpenCV Model Zoo, and I'm going to introduce the models, demos, and benchmarks on popular edge devices. So in this talk, I'm going to split into three sections. The first one is introduce the overview of OpenCV Model Zoo. And next is how to use our models in the zoo. And the last session is about the big thing and the future plans for the zoo. So first up, introducing OpenCV Model Zoo. So what is OpenCV Model Zoo? So actually our repository name is OpenCV_Zoo. And on the left is the front page of our repository, and you can scan this QR code to visit it. And I'm going to show you the page of our Model Zoo. Let me switch between windows. Yes, this one. So the front page of our repository looks like this. It contains three directories for now, and we have the license, README, and some configurations here. So the most important directory is the models directory, and actually it contains all the models we have for now. It looks like this. And For the benchmark directory, it contains the benchmark system framework and the benchmark configurations and also some instructions on how to run the benchmark of the zoo. And the third directory is the auxiliary tools that we use for quantization and model evaluation, which gives us about the accuracy of the models. So this is the basic structure of our OpenCV model zoo. And actually in the front page of the zoo, you can see the README here. First up, you'll see the guidelines to how to clone this repository to have all the models and demo scripts. By the way, you need to install Git LF service for large files storage to get all the models using the git clone command. And we always recommend that you should install the latest OpenCV Python to experience all our models here. And follow-up is the section for models and benchmark results.
Can I add one little note here?
Okay.
So so a lot of people who only likely use Git, they don't have not used Git or GitHub. They may have cloned a repo. One thing to keep in mind is that these model files can be large, and that is why you need the LFS, which stands for large file system, in Git. And you have to use that. Otherwise, you will not get the model. So follow these instructions carefully, and you should be able to get the models. But just to give you a context on what this LFS means, usually Git was initially created for these little files, right? I mean, text files, they don't take much space, but model files do. And that is why you have this extra step.
Yeah, and binary files like that don't compress well or at all, really, most of the time. And they're not just hard to compress, but they're also difficult to do diffs on easily, unlike a lot of source code documents that are just what line changed. You can't really do that with stuff like images and videos. It just doesn't really work that way. So yeah, totally.
Yeah, normally speaking, when you have the default installation of like Ubuntu or Mac OS, you'll have Git worked out of the box, but it does not install the LFS service. So you need to visit this page, which is git-lfs.github.com, and see how you can install the LFS service following the instructions there. So basically, we use this service to store all the model weights or say model because they are pretty large files and they need to be carefully stored. So we use LFS to do this. Yes. And follow up, let me introduce this big table here. It's pretty long, and let me help you to understand this table. So on the leftmost column, we have all the models in the zoo. We have, for example, UNet for face detection, S-face for face recognition, and all these models here. And the second leftmost is the task that this model works for. And when we talk about the latency of a single inference of a model, or the time cost of the model running a single inference, it actually depends on its input size. So we have input size in this table as well. And for UNet, you can see if our device is Intel CPU, which is, if I remember correctly, yes, it is Intel Core i7 12700K, and it takes about 0.72 milliseconds to do a single inference on this input size. And followings are different devices. and they are all in milliseconds. From this table, actually, you can choose based on your task for sure, and you can choose the model, and you can choose which device you want to run on to save like the cost to achieve the best efficiency. And yes, and here are some notes about the devices that we have in the zoo. And actually, we contain the model of the device and some basic specs. For example, the number of cores, gigahertz, speaking the frequency, and something like that. Threads for sure, and you can click this hyperlink to visit the detail to visit and see the detail specs. And the third section of this README is about some examples that we run with our models and demos in the zoo. For example, we have face detection with Yuantao, where you can see in this world's largest selfie, basically every single person in the front here have their face detected with 5 landmarks detected as well, and facial expression recognition.
There are 5 points also that Yuantao automatically detects, right?
Yes. It is, yeah, it depends on the model, and Yuantao produces like 5 landmarks, which are the center of the 2 eyes, the left and right corner of mouth, and the nose tip.
Yeah. So this Yuantao is it already the default? I cannot remember. Have you made it the default model for face detection on OpenCV or not yet?
I would say yes, because this API is from the object detect module.
Okay.
And actually, I have introduction to this API like in the following sections, in the following slides. Yeah, and all the examples you can see here, basically, yes, you can run our demos and get the same example outputs. So this is the overview of our OpenCV Zoo and the basic structure of our OpenCV model zoo. Let's get back to our slides. Okay, next page. Yep. Okay. So speaking of model zoos, we have like various model zoos now in the internet. You have the Onyx model zoo, the Hugging Face. I'm talking about like the world's biggest model zoo in the like currently in the world, and the Paddle model zoo from Baidu Paddle. So what's the difference? And what's the differences like among these zoos? Firstly, I would like to talk about the size. Well, from what you just saw just now, you can see that there are not a lot of models in our OpenCV model zoo. Actually, we favor a compact model zoo where we do not provide like too many choices for users, because actually too many choices would make confusions. Like users do not know which model they want they need to use for a specific task. And well, Hugging Face, actually it has extremely huge size, and it contains like basically every single model in the world. And the model zoo from Paddle is like it serves the academy and the industry, and it is a framework developed by Baidu, a Chinese company here in Shenzhen. And speaking of Onyx model zoo, it has a medium size. It actually does not care about the quality of the model. It just needs to like contain every single like just one model from like different types, and it needs to prove the representation ability of ONNX formats. And so model formats of our OpenCV SU actually it should be all the model formats that OpenCV supports, but currently we favor ONNX formats because it is the most popular format when we are talking about deployment, something like that. And Hugging Face, it has models from PyTorch or TensorFlow, and Paddle models, so obviously it must from Paddle. And features, when we are talking about features, I think this is the most different thing that we vary from other model SUs. Models in our OpenCV model SU are deployment ready, and every single model is well chosen by OpenCV China team. And well, the biggest difference is we have all the hardware comparison, which is the table I just showed you just now. And this is the biggest difference that we vary from other model SUs. And obviously, all the models in the SU are free to use, and most of the models is licensed under Apache 2 license, and they are free to use. So these are the differences from other CV model SUs when we are talking about OpenCV model SU. So we are going to the next section. Excuse me. The second section is about using models in the SU. So this is on the right side is the table I just showed you. Actually, you can use these tables for two purposes. The first purpose would be like it guides you how to choose the device that you want. For example, if you are going to build some smart devices at home to like, I don't know, something like Alexa, which can play music for you. First of all, it needs to recognize your voice. And if you want to deploy such a thing, you want such a device to be like efficient enough, so it does not cost you too much about like the electricity bill. So when we are talking about this, obviously you cannot run these models on Intel CPU because it is very power hungry, and you want to deploy on Raspberry Pi CPU. So if you are going to do that, for example, you can see UNet, which is about the face detection. It runs 6.22 millisecond on Raspberry Pi CPU. It should fit your needs, but it depends. And if we are talking more about like performance, you'll see here we have the ResNet from Paddle, and we call PP ResNet for short. And you can see here, if you want it to run at the maximum speed, you will probably go to the Ascent 310, which is from Huawei, I think. Yes, it is MPU devices. It is a development board with MPU equipped, I think. Yes.
And how does the price? I just want to learn the Ascent 310. How does it compare to, let's say, the Intel CPU in terms of price? Is it half the price or is it same price?
So the Ascent 310 is equipped on a development board, and they sell the board for like 1K RMB, which is about like just shy of $150.
Okay, that's
US dollars,
pretty solid, right? So this
benchmark, and it's way cheaper than Intel CPU.
Right. So this benchmark also helps us select, okay, we have this application. Intel CPUs are great for other things, but if you want just this application, then we may be able to use a much cheaper device instead of going a full CPU.
It helps you save like the price to build such a platform.
Yeah.
And it also helps you save energy
Yeah.
to achieve like the balance between cost and efficiency.
Yep.
Got one quick question from the audience here about the benchmarking. They're asking, it seems like the Jetson number there is pretty high, especially for UNet there, 12 versus 1, which is a big difference. They're asking, how are these models optimized before benchmarking? Like, are there any specific, like what specific hardware optimizations are made before this number comes out?
Actually, we use the same model to like run on these devices. And we compile OpenCV with different backends enabled. For example, when we are talking about Jetson GPU, we compiled OpenCV with CUDA enabled, and we run the same UNet Onyx model to get this number. And the same for other devices as well.
Okay, so there may be other, go ahead, Satya.
No, so I think it is surprising, right? That number is so high for a Jetson, which has a GPU compared to other CPUs. But I think if you look at other model, it could be very specific model architecture, which somehow is running fast on CPUs compared to GPUs, right? But I'm guessing that most other models would run much faster on the Jetson GPU because we are using CUDA in the end, right? So
yeah, but actually, like the GPU on the Jetson Nano, is not like the same performance of the desktop GPUs.
Of course.
It's more targeted on mobile platforms.
Okay, yeah. So even though we call it a GPU, it is more like an NPU in performance.
Yeah, I would say, something like that.
And of course, as always, your mileage may vary, and there may be certain optimizations on a per model basis or a per hardware basis that we're just not aware of here or aren't using for other reasons. So these numbers are not like the be all end all. They're just an attempt at an apples to apples comparison, based on the commodity hardware and software.
Yeah, but at least if you're using these models, you know that you can get this and it will perform at this level. So without doing any other optimizations out of the box, this is the performance.
Everything is worked out of the box, and you do not need to buy this device to test. Every single result you want to know is like right here in the table.
Yeah.
Okay. Shall I move on?
Yeah.
Okay.
Yeah. Thank you.
So highlights. Okay. So highlights of the models in the SUE. So currently we have 16 well-chosen models serving like for 14 tests, and we have models in different accuracies. For example, models in FP32 stands for float 32 accuracy, and we also quantize. Basically, we quantize every single of the models into integer 8, and we have just supported FP16 in OpenCV DNN like last year, and it is still an experimental feature. These models, they are from the OpenCV development team. For example, OpenCV China, this model UNet is actually from our team. And we have OpenCV area chair, and actually we select like professors from different universities, and every one of them put like one model in the SUE, which you can see here. For example, S-Face for face recognition is from one university in China. And we have community source as well. For example, in the last year's GSOC, which is the Google Summer of Code camp last year in summer, we have two, if I remember correctly, we have two of three projects in GSOC, and we asked the contributors to find or train like one or two model and put it in the zoo. Sorry, excuse me. There's a mosquito here. Yeah, okay, it's fine. So well, for each model here, we have at least one demo to show how to use the model, and the demos are in Python. And actually, we are planning to give models in C++ as well.
Right. Can I add a little bit of color to a lot of people may not understand how OpenCV development is organized, and I might just take a little take this opportunity to explain how things are organized. So OpenCV, OpenCV.org, which is the nonprofit that supports the OpenCV library itself, doesn't have any developers, right? There are developers from other organizations who contribute. And so there are people from OpenCV.ai, which is the for-profit arm of OpenCV.org. And we have several developers, about 4 developers who work on the OpenCV library, accept pull requests, etc. And then we have OpenCV China, where there are at least 3 people. Yuantao, can you?
Yeah, actually, we have 5 people in OpenCV China, and 4 of them are developers.
Right, right. So, for example, Professor Shichi Yu, I mean, the unit is after him, right? And you guys have worked on it, right? We also had a team in Intel Russia, but after the war started, that was Intel pulled out of Russia. So we do not have that as a team yet. There are still people who are contributing as individual contributors. And then we have from the community, we have Google Summer of Code, which is organized every year. We get about 10 interns, which are supported by Google to work on the OpenCV library. And there are volunteers these are mentors on OpenCV who help the students to get in. And usually the applications are available in February, March, and April 4 was the deadline before which you had to apply for GSOC. Unfortunately, it is already passed for people who are listening and might be interested. But that's one way we support. And then we have OpenCV area chairs. What we did was we reached out to the community, and especially professors and people who have teams, small teams working with them, and we asked them to contribute to the OpenCV library. And these are all volunteers, so they take up specific segments. For example, there is a team that is working on face recognition, and that team contributes, the area chair, face recognition area chair, and their team, they contribute to the OpenCV library, a model, and they keep updating the model. And it is their job to keep, the best model out there. So those are the different ways in which, OpenCV library gets updated. And while I'm at this topic, I can also ask for this. For the first time, actually, we are asking people for donations. If you guys are able to, on GitHub, we have a membership service we started just recently. And for $9 a month, it's a donation, right? We will continue developing the OpenCV library, and it would really help us if you guys can contribute $9 a month. If you're a small company, we have a good deal for you. Like, you can contribute about $499 a month, and that would you would be listed on the OpenCV website as a bronze member. I have not put the list yet out yet because we just published this. But this, this donation program is going to help OpenCV library. And the entire amount is going for the development. There is no other overhead in our organization. All the top the executives who are responsible for this, they get paid $0. In fact, I have a Gary told me when I became the CEO of OpenCV.org, he said that, you will receive a salary of $1 per year. The first year, he did send me a check of $1, and then he doesn't even send that.
So, I mean, Gary's got to owe you like $3 by now.
Right, he owes me a lot of money.
That's folding. That's folding money, buddy. That's folding money.
Right.
But yeah, you can. So, folks, you can check this out by going to github.com/OpenCV and clicking the little sponsor button at the top of the window to get all the information about that. As Satya said, there is a $9 a month tier, and you'll get a nice little sponsor badge to show people that you support OpenCV on your GitHub profile. Organizations can donate more per month, $4.99 per month. So please check that out and help us continue to build out the world's biggest computer vision library, and it's free and open source. Ain't that something? Right.
And the other thing I wanted to mention also is this membership program. Right now, it's a pure donation, and you do not actually. I mean, you feel good about yourself that you're supporting the library that you love, but we are also thinking about rolling out a membership program so that we can give out something in return. And I'm thinking that, okay, we'll give out discounts on the OpenCV courses, we can talk to, we can get discounts on the OpenCV AI kit and other things. We're still developing the ideas. And if you have ideas on how the membership, what you would like to see in a membership service, I'd love to hear from you.
Yeah,
you can send us an email.
Just a suggestion from the peanut gallery over here. Maybe DRM-free downloadable editions of this very show. That could be something that people get as part of this thing down the road. And as you were just saying, sorry to cut you off there, you can get that, be the first person to know by going to opencv.org/subscribe. And if you have your suggestions, send them to newsletter@opencv.org.
All right. That was a little plug for the library that we all love. So I don't even feel bad about that.
No, absolutely not. And, I mean, before we continue, I just want to say quickly too, big shout out to, there's also tons of different, not even affiliated with OpenCV projects doing bindings for, like there's the OpenCV for Node team, shout out to them. There's also bindings for Rust, et cetera, et cetera. And those, we're not even working on those internally. Those are just the community.
That's great. Yeah. Thanks for bringing that up.
All right, back on with the show.
Okay. So I'm going to show you. For each model that we provide, we have, for example, demos in Python, and we are adding C++ demos as well. And models and model weights, they are in FP32 and integer 8 accuracy, and we are trying to put FP16 into the SU as well to save like the size of the SU, and it helps to decrease the size. And the license, which is important because it gives you the intention that we want to we all want to use this model for free, and we do not cost you anything to use this model. And we have the examples directory, which has the example outputs, for example, the images that I just showed you. And the README, it contains the references to the original paper, the original repository, which trains the model, and some explanations to the model, something like that. And let me introduce the structure of each demo. We have 3 sections in each demo, and the first section is going to be the command line arguments, Actually, we have like two kinds of arguments here. The first one is going to be the shared arguments, which is shared across like different demos. We have input for sure. If we do not specify this option, we'll use the webcam as input by default. If we use this option, we'll need to give the path to the image for example, to run this demo, and the path to the model, and we need to select the backend and target pair to run the models on. For example, it runs every single model on the default OpenCV implementation and on the CPU. And we can run this demo on CUDA as well. And the new TeamVix backend and CAM backend we just added last year to run these models on MPU, which requires a specific device to run on. And we also have other shared arguments. For example, this save and this vis for visualization. If they are specified, it means this demo is going to save the results and is going to show the result image in a new window. And we have the specific arguments as well, and these are model specific. And for UNet, we have two thresholds, and this one is for thresholding face boxes with confidence and NMS to filter out like duplicate boxes. And top K is used to keep top K bounding boxes before MMS. And this is the command line arguments of each demo. And following, we have the visualization function to show the example outputs. For example, in UNet, we need to have 5 colors for each landmarks, and we need to draw this bounding box along with the face score on the top left corner of the bounding box. And we draw all this information on the original image and return it for to show it in a new window. And the third section is about the main function, which is how we initiate the model itself and how we deal with the inputs. For example, if the input is an image, we read the image, do the inference, print results in console, and we draw these results on the input image using the visualization function I just explained. And if the user wants to save the results, we have cv.imwrite to save the result image and open a new window for visualization as well. And if the input is omitted, we call the default camera, which takes the webcam stream as input, and it gets every single frame from the webcam, and we do the same steps to show the results. So this is the demo script, and we do the same thing if we are talking about C++ demo. And actually, you see that we have a UNet class here, and the content of this wrapper class is actually, we are calling cv.faceDetector.yn from the object detect module. And it builds the UNet class. For each wrapper class, we have similar shared functions. For example, init, where we store key arguments and create the model instances with OpenCV DNN APIs. And we have the name to return the class name, which is the UNet here. for this class, and it is used in the benchmark system to distinguish every single model. In the benchmark system, we support running benchmarks on different backends and targets, and we need this function to set the model to run on different backends and targets. And the most important function is the infer function, which runs the model inference on the given outputs. And we also have specific functions as well. For example, in UNet, we need to set input size before inference. Therefore, we have the set input size here. And these are the example outputs that are also shown in the previous section. We have UNet for face detection, human seg for human segmentation, text detection, object tracking, and hand pose estimation as well.
One
Okay.
small note about this object tracking is that it is a generic object tracking. You put a bounding box
Yes.
around the object and it tracks whatever object you want to track. Doesn't need any training for that specific object.
Yes, yes. It just worked out of the box without any like training, something like that. You just need to select the object that you want to track, and you press the enter button, and the demo just track the object.
Yeah.
Okay. So actually, we have applications, which a student from our university use the models in the zoo to control the robot dog with gestures. Let me play the video here. So you can see here, when we do this gesture, it controls the robot dog to move forward, and you can make it go back, and
you shall not
this gesture
pass.
just stop it. Yes, yes, exactly. And you can make it spin as well. Nod his head, shake his head.
What did I miss? What
Yeah.
what kind of dog is this? What kind of robot dog is this?
Actually, you can see it from like here, the mini window here.
So what's the brand?
I do not remember the brand, but it works like it's not the same tier of like the dog from or the robots from Boston Dynamic, I think. Yeah, it's not the same tier. It's like the robot dog was originally designed for like agriculture purposes. So you in such like if you are talking about like watering plants, something like that, you can control these robot dogs like with your gestures, something like that. It's pretty cool, I think. And okay. So I just explained that OpenCV DNS supports like different backends and targets. We have the default backend for running on CPU and OpenVINO backend as well. For GPU, we have the Vulkan backend and the CUDA backend from NVIDIA. We have the TeamVex backend and the CAN backend for NPU. And for models formats, we support Onyx, TensorFlow Lite, which is just supported like if I remember correctly last month, and Caffe and Darknet. We use OpenCV to benchmark all these devices, all these devices and hardware. And currently in the zoo, we have 1, 2, 3, 4, 5, 6. We have 6 devices now in the zoo. The first one is the Intel CPU. The model is 12700K, and we have Raspberry Pi 4. We have NVIDIA Jetson Nano B01. We have Cadus Wim 3, which has a 5 TOPS performance NPU in it, and the Atlas DK200, which runs the CAN backend and achieves I would say amazing performance. And we also have the RISC-V based CPU All-Winner D1 development board here. And basically you can see 5 out of 6 are edge devices. And we are thinking about like making OpenCV like sort of a library that people want to run on edge devices, and it helps them to achieve like the best performance on these edge devices. And this is why we favor edge devices. And
Yeah,
actually, we are planning. Yeah,
a few people have asked about other devices here during the show and like why they're not there. And probably, I mean, the answer is we don't have one to test with, and it's not trivial to like hook this stuff up and do it. You know, we're running this stuff on real hardware, and so it takes time and money and expertise to do that. You know, one of the ways to maybe help that happen is by supporting OpenCV on GitHub.
Right, but there is also a development program. So,
yes,
for example, exactly. I just want to bring this up for people who are probably working at one of the companies.
Thank you for picking up on my segue, Satya. I was hoping you would do so.
So one of the companies, for example, Kadas is one of the companies that helps us. They are a development partner, and what they do is, you know, we develop features which work on their system, and it is all open source. They, you know, everything that we develop goes into the open source library. But we also help them, as part of the deal, they also get to, we also benchmark these models on their hardware, right? So we do have a program for companies who want to have their hardware supported and benchmarked. So again, reach out to newsletter@opencv.org if you have any questions about that. We'll be able to give you some details.
Yes,
yeah,
indeed.
actually, we are planning to add more devices into the zoo this year, and at least 2 devices are tested for now. And yeah, we need more hardware in the zoo. Yeah. And actually, we are open and welcome users to give like proposals or advices on this, and tell us which device you want it to be in the zoo. Okay, next up is about the table again. So the table here we show it has all these numbers, and these numbers are fully reproducible. We are talking about open source code with like all the scripts opened. We have the framework of the benchmark system open sourced, and the benchmark configurations as well. And most importantly, we use specific data that we collect from the internet, or we just capture from our live. We need such data for benchmarking, and we also uploaded this data into let's say Google Drive and Baidu Net Drive for people to download this data if you are interested to run benchmark on your own system. But you make sure you need to have Python installed, and OpenCV Python for sure, and some other dependencies. And one more, and I want to address that we are open to add other devices, and we need suggestions from our audience here. And what device that you want to see in our zoo, please you can go to the issue page of our repository and create a new issue to tell us which device you are interested in and want to put it in the zoo.
Yeah, and it's super easy to find. Just github.com/opencv, and you'll find the OpenCV_zoo on there.
Yes,
and that's where you can tell us what you want to see.
Yeah. And we also provide additional tools for quantization and evaluation. We use Onyx runtime and Intel neural compressor for quantization. And we already provided evaluation scripts to evaluate models on ImageNet, wider face for face detection, LFW for face recognition, the IC DAR and triple IT 5K for text detection, and the mini supervisory for human segmentation. These scripts and the data set itself, if everything is like reproducible with code and configurations, and actually we are calling help from the community to contribute more evaluation scripts. And actually we want to know whether the accuracy drop when we quantize the model into, for example, integer 8 accuracy. And we need help from the community to do that. And the final section is about the big things for the zoo in the future. Once again, we are going to add more devices. For example, RISC-V boards, even cell phones, like the Qualcomm chips, something like that. Recently, a hit topic is about the AIGC models. For example, GPT series. The GPT is something like from the closed AI. So we have to find alternatives to that. For example, the mini GPT-4, Alpaca, Llama, Dolly from like open source contributors. And we are interested to run these models with OpenCV on different devices. And we are also looking for running a stable diffusion or mid-journey, which generates a lot of paintings or arts. And we are interested to run it on different devices with OpenCV. And one of the important thing at the end is we are debugging and running the cutting edge model. For example, the SAM, segment anything model from Facebook with OpenCV. And the good news is I can leak some good news here. And actually, I managed to run SAM with OpenCV, like plain OpenCV.
That's sweet.
And it can run on CPU, for example, CUDA for sure. And I'm going to try to deploy it on for example, the Ascend 310 I just mentioned in the previous section, and it will achieve amazing performance, I think.
Awesome. That's exciting. I didn't know about that development. That's really exciting.
Yeah.
Because Sam came out.
I just make it work this morning.
Okay. Very nice.
Yeah, awesome. You go ahead and unshare your screen here.
That's it. And thank you everyone to listen to my talk. And I think here is the question section, right?
Yeah, absolutely. We really appreciate it. Yes, thank you. We'll go ahead and turn off your screen share here.
Okay.
If you please.
Okay.
I think I can do it actually.
Okay. I just pressed.
I'm the captain now. Good morning, everybody. Thanks so much. Thanks so much, Yuantao. Awesome presentation here. I learned some things about OpenCV Model Zoo. I hope that y'all did as well. This is the time in the show when we give away something to you in the audience. During the show, I came up with a little trivia question that I'm going to ask to you here in the Zoom chat. The first person.
Can I interrupt a little bit?
You can go right ahead.
Well, so we have been seeing that people have been reading your mind, and as soon as you say a few words in the question, people reply with an answer. For a change, can we ask people to just give the answer? Not the question will come later.
That's a tough one. That's a tough one. I think we'd have to like put the question in escrow or something, right? So it was, I couldn't change it.
You cannot change it.
It depends on how much people trust me. Depends on how much people trust me. NSA in chat here just said 42. Good guess. Always a good guess. It is often the answer to life, the universe, and everything. The way this works is I'm going to ask a question. You're going to answer in the Zoom chat. If you have won in the last couple of months, please do not answer and give someone else a chance to win. The prize you're competing for is the OpenCV course of your choosing. You can see what is available in the catalog by going to opencv.org/courses. Most recently, of course, coming up soon, in fact, in early May, we will have the OpenCV Mastering AI Art Generation course will be available for people to purchase after the Kickstarter campaign, which was very successful, and now it's available on Indiegogo as well. You can still save a couple of bucks if you go on Indiegogo and search OpenCV. What you're going to win here is the course of your choosing, including that new one whenever it becomes available. We got some good answers in the chat here. Peeled banana from Steve Simpson. Dan Beaver said Sam. None of these answers are correct yet, so I feel a little bit better about our odds. All right, get ready to answer. Earlier in the episode, we talked about the new way you can support OpenCV by pledging some money on GitHub by going to github.com/OpenCV and clicking the little sponsor button. Who can do that quickly enough to tell me what the monthly price is for individuals and for corporations?
Okay.
You gotta do both. Oh, there we go. I think we got one. You tried. Timothy, it looks like Timothy got the answer. The correct answer is $9,499. Congratulations, Timothy. Please send, that was exciting, huh? Please send one email to phil@opencv.org and I will make sure that you get the course you want. You can go to opencv.org/courses and see what we have available and pick any one of those, none of the bundles, obviously, but any individual course can be yours. Just let us know. We've got a couple minutes left, but I think we answered like pretty much all the questions we got during the excellent presentation here. I'm just going to take a quick look in the Zoom Q&A here. So one person's question was, what are there plans to add any more desktop GPU or CPUs to the benchmark data here? You talked a lot about, we're trying to focus on the edge, but are there any plans to add more desktop stuff?
Yes.
Yeah. Are there any any in particular that you wouldn't mind saying? If not, it's okay.
Yeah, I mean, it depends on the hardware that we have for now. For example, we have the 12700K for CPU.
Right.
I'm talking about the Intel CPU 12700K. And actually, we have the NVIDIA GPU. I think the model is 1080 Ti. Except for that, I don't think we have other device for now. I mean, if there is a great demand on this like desktop grade CPU or GPUs, we can put them in the suite as well.
Yeah. Thank you. Good answer. Yeah. And again, as support increases, maybe we end up getting more devices on there through your generous donations. No promises, but we'll do our best. Satya, there's one thing we haven't talked about yet on this week's episode, but it's important because we'll be talking about it a lot next week on the show, which is Copycat. Do you want to talk a little bit about Copycat? Introduce people to the new service from OpenCV.ai?
Well, so I don't want to steal Anna's thunder, but I can give out a little bit of snippet. So basically OpenCV.ai, which is the for-profit organization that helps fund a lot of OpenCV.org stuff. We have come up with a new idea of generating almost infinite data from existing data, right? So think about problems like segmentation, etc. It's very difficult to generate ground truth data. And we have come up with a very clever way in which, this data, you have existing data, and it basically creates a whole bunch of other data. Just imagine, let's say for human pose estimation, you have one person, right? You have basically marked one person, the body pose of one person, and now you can change the person completely, right? It would be the same body pose. The ground truth would remain the same, but the background could change. The person could change. It could be, completely different person wearing different clothing. And I'll let Anna talk about the details of that project when we see. Is it next week?
Yeah, we're gonna.
Okay.
We decided to do it next week. They're chomping at the bit to promote. And we've talked a lot about data augmentation with Joseph Nelson a few times on this show, and how
this is a completely different level. I was blown away when I saw. Some of the results.
I've seen a bunch of the examples here, and it is really impressive. It's not just simple things like we talk about, like maybe rotating or like darkening the image. It's a whole different level where actually physically changing the aesthetics of the scene to 10x your data in minutes. So
and it's also buzzword compliant.
Exactly.
It's got diffusion models. It's got all those things, right? So
That's right.
it takes things to a completely different level. And how all these things in the last week alone, we have seen so many different things come out. It's just sometimes it's scary the pace at which innovation is happening. Like we saw SAM, we saw Dino V2, what else am I missing? Oh, the stable diffusion stability has come up with its own stable language model, stable LM. So it's just mind-boggling. And also the other thing to keep in mind is that all these things are converging, right? Earlier, we used to think, we are a computer vision library, or we are a computer vision company. But now it is all, AI is converging in some sense, that these large language models are actually helping with, things like, for example, stable diffusion. It is a combination of, it was trained on these large language models as well as, images. So we are in this stage that all of AI is converging, and also the paradigms are shifting completely. SAM is a great example where people are saying that, okay, now you just need one model for all kinds of segmentation. And I have tried out the demos, etc., but I have not dug deep into it to see how substantial the change is. And my guess is that it is very substantial, right? So yeah, exciting times, and
Absolutely.
all these AI libraries are going to converge. That's why we are also adding, in OpenCV, we added speech a while back, and now also for large language models, we'll start adding support, because these things are very much intertwined now, and we cannot separate one from the other.
Yeah, totally agree. And we talked about this a little bit last week. With the advances and with these huge, just like SAM, the segment anything model is one of those things that is almost in like an epochal thing where so many startups just became features.
Right.
Like there's a lot of companies out there that just got torpedoed, and that's gonna, hey, that's always going to be a risk when you're in a fast moving field like this, which is why it's good to diversify and skill up so you can skate to where the puck is going to be and not where the puck is. But we're about 5 minutes after the hour. You want to go ahead and take us home, Satya, with that in mind?
Yeah, thank you so much, Yuantao, for this excellent presentation. It is good to have an OpenCV team member. And I just wanted to give some background also. This is the first time we had an OpenCV.org meeting in person. Usually we just have Zoom calls and stuff like that. And we met in Turkey recently, and that's where I was, got to meet all the team members for the very first time. So it was an excellent, and we'll do it annually every year. We'll do a live meetup. So thank you for the presentation. It was awesome, and OpenCV Model Zoo, it is one of those initiatives by OpenCV that we want to make sure that if you want to do something interesting, you don't have to go out and have to, quantize your own library and bring it to OpenCV, etc. You have the basic things already there, and then we'll keep adding the best-in-class things as more and more models become available without completely, we don't want 10,000 models, right? We want 100 good models eventually, right, which solve specific problems.
Yes, exactly.
And that's the way we are going, and also focusing on benchmarking, as well as these models. When we train these models, they are also optimized, right? There is a lot of time and effort spent in optimizing it for regular hardware, edge hardware. So it's a great initiative, and thank you so much for your team, Professor Sichi and the entire team for this initiative. It's really great. And thank you, Phil, for organizing this. Nothing went wrong, so nothing, I cannot blame you.
Hey, there's still time.
All right. And thank you so much for this amazing audience. You guys show up every week, and we have a blast organizing this webinar. Thank you. And don't forget to support the library if you can.
Yes, damn Skippy, go to github.com/OpenCV, click that support button or sponsor button, whatever it says. It's new to me too. And don't forget to join us next week, same bat time, same bat channel, Thursday morning, 9 a.m. Pacific time. We'll be talking about Copycat, the new way to 10x your data in minutes. We hope to see you there. Take care of yourselves out there. Take care of somebody else if you can, and have a great day wherever you may be.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.